Welcome back, everybody. This is the final of 5 parts in my video series on radicals. If you haven't seen the first 4, please go take a look at those now because they're going to be really important to your understanding in this video. In this video, we're going to be talking about rational exponents and how to undo those using radicals. Let's jump in. So what do I mean by a rational exponent? Well, a rational number as an exponent. Remember, a rational number is a fraction of integers, right? Or it's a non-repeating, non-terminating decimal. So they are things that look like some number a to the power m over n. The way that we represent these is as the nth root of a to the m, or the nth root of a all to the m power. Notice that these two expressions are the same because, remember, I can write this as a to the m times 1 over n, and we know from our properties of exponents that when I have powers to a power, that's the same as multiplying those powers together. So using that property in reverse, I could write this as a to the m all to the 1 over n power, which is this guy. Or I could write it as a to the 1 over n all to the m power, which is this guy. So those two on the right are definitely the same. Let's take a look at how to use these things a little more carefully, though. In part A, I've got 64 to the 1/2, and in each of these parts I'm asking you to simplify them. Well, this is one of the powers we've already looked at. Notice the numerator becomes the new power, and the denominator becomes the index on the radical in our rule up at the top. So here, this becomes 64 to the 1 power under a square root. 64 is a perfect square, so we get 8. Let's try the next one together also. Here, the power, or the numerator 1, becomes the new power, so I've got negative 125 to the 1 power, and the denominator 3 becomes the index on the root, so I get the cubed root of negative 125. Now, this is also a perfect cube. It's negative 5. Part C is a little trickier. Here I've got something other than 1 in the numerator. I've also got a negative exponent. But we know how to tackle all of these parts separately. Let's just handle one piece at a time. To handle that negative exponent, I bring the whole thing into the denominator, and I get 81 to the 3 over 4. Now, let's tackle the rational exponent. The numerator becomes the power, the denominator becomes the index. When we deal with larger numbers, it's easier to use this second one, because by doing the radical first, it'll cut the number down. Let me show you what I mean. Here, it'll be a little bit easier to simplify by writing this as the 4th root of 81 cubed. Because 81 happens to be a perfect 4th power. It's 3. And now 1 over 3 cubed is 1 over 27. It would have been much harder to cube 81 and then find the 4th root of that. Go ahead and pause the video here to see if you can do the last one on your own. First of all, I simplified my coefficients. 32 over 16 is just 2. Now I can simplify my powers of x using my properties of exponents. Remember, when I divide like bases, I subtract their exponents. So I get 2 times x to the 5 over 3 minus 3 over 4. That comes out to be 2x to the 11 over 12. And using my rule up at the top, I can write that as the 12th root of x to the 11th power. In this video, we learned all about rational exponents, and this is going to wrap it up for our series on radicals. Thanks, guys. Catch y'all in the next series.